Hello and welcome to the Srijan Wednesday webinars. If you're joining us for the first time, this is a community initiative by Srijan Technologies where you can tune into some great sessions on topics ranging from front-end technologies, UI, UX, mobile apps to media, entrepreneurship, community building, and digital marketing. In today's webinar, we take a look at React.js and how it's more than a simple JS library. We have with us Jyoti, Puri, who will take us through the fundamentals of React and shed some light on how it solves the challenges faced in current web application development. Jyoti has over 10 years of experience in developing web applications, and she recently co-founded Humble, which is a web development and consulting company. Before we get started with the session, I would request all participants to please type in any questions that you have during the presentation, and we'll take them up in the last 15 minutes of the session. Also, please don't forget take the conversation or hashtag SrijanWW. You can share your thoughts by tagging us in your tweets using our handle @Srijan and Jyoti's handle, which is up on your screens right now. So without taking up any more time, let's get started. Jyoti, over to you.
Yeah, hi everyone. I'm Jyoti, and I'll be talking today with you about fundamentals of React.js. React.js is a front-end development library which has been developed at Facebook. It's a library for building user interfaces, and yeah, so let's get started. About me, I'm Jyoti, and I've been doing web development for a long time now, about 10 years. I've experienced in various technologies in front-end, back-end, and a lot of web development frameworks, libraries. And recently I founded this company, Humble, and we are mainly into web development and consulting, and we do a lot of work in React for web development using React.js and also React Native. Yeah, so I'll get started. So the main core problem of web development is developing modern-day web applications is hard and it's complex. Maintaining them is even harder because modern-day web applications face a lot of challenges in terms of the great UX they're expected to provide, the number of devices they're expected to support, the number of browsers, the number of bandwidths, and doing that in a very reliable and maintainable way is a huge challenge. The same challenge was faced by developers at Facebook, and then they came up with this concept of React, because the web development technologies, which are like HTML and CSS, are not made for the complex use case of modern-day web development. And various other libraries and other technologies try to address this complexity of modern-day web development in various ways. You might have used a lot of traditional MVC frameworks, which have this three-tier architectures with a lot of crisscross data flow and data binding. But what it all results, but as your application size grow, it results in something like this. With a lot of crisscross data flow, your applications are no longer reliable, and maintaining them is even a nightmare, because if you're changing your application anywhere, you don't know where all is going to get impacted, and what fixing one bug or making one change may result in a lot of effects at places which is like really hard for you to make out. And this is the result of the kind of frameworks we have. Then came up with improving these, but React actually challenged these best established practices like MVC. React is not another web development or MVC framework. React is a library, just a library and an architecture for building application, and it challenges a lot of these best established MVC frameworks. What are the fundamentals behind React? React is mainly based on these core philosophies, I think, which is a functional approach to UI rendering, unidirectional data flow in your applications, then do not mutate, re-render the application, And in front end, React has, in browsers, it has an abstraction of virtual DOM. As we go through the presentation, these things will become more and more clear to you. But just to give an idea, so React and React kind of, as I told you, these front-end technologies, HTML and CSS, they are not great at solving the current use case of rich web applications. So React creates a layer of abstraction over these technologies. On browsers, it's the virtual DOM, and then they create functional components which output a virtual DOM. Virtual DOM is a level of abstraction before your real DOM, and this level of abstraction over the technologies like HTML and CSS, which are great at handling things like state, a lot of states which modern day applications have. Having this abstraction layer opens a lot of other possibilities in front-end development. For instance, React supports server-side rendering, rendering to any string, rendering to a platform other than browser, which is done in React Native. It supports things like hot reloading, which is not possible with any other front-end library. As I told you, in core of React is a React component, which is a functional state management machine, I would say. I'll tell you more about the React component to start with. So React components. So React components, not like templates in a lot of other front-end frameworks. React components are pure functions, and the output of the component is the state of your UI. If you're using a browser, then in that case it's the state of your DOM, and if you're doing React Native, then it's the state of your mobile screen at any point in time. And components are not just widget, they're actually a part of your application and a part of your application structure. So and they interact with the parent component, the child component. So they're actually right there, and they're very much more meaningful in your application. Yeah, components, as I told you, they're like state machines. I'll show you a simple React component that will make things very clear. So a very basic React component looks like this. This code is a very basic Hello World React component, and here in the HTML you see the output of this component. And so you see a React component is made by calling this method react.createClass, and we are passing a simple JavaScript object to this method. This object should have a render method which returns to you the state of DOM at any point in time, and then I call this method to actually connect this component to actual DOM element. So in this case, it's this div, which has an ID container. So React, which you see here, is a core library of React that has all the generic code, like this create class is used in React and also React Native. And as I told you, React creates this level of abstraction, and then React enables rendering to various platforms, not just the browser. React DOM is something which is specific to browsers. In case you're doing React Native, you will be using React Native libraries to do actual rendering to mobile platforms. But then the core of your application, the heart of your application logic, largely remains the same with React and React Native. It's just these components. In case if you're using React Native, it will be some of the native component. If I'm using React DOM, it's these div component. React also opens this possibility of rendering to other targets other than the browser, like might be the browser can. One example is going a little low on the browser itself, which is like, or Canvas. That's also a possibility with React. And React handles your app state in a great way. So, and this abstraction handles rendering to different targets in an awesome way. Yep. So what you see here, which looks like HTML, is actually not HTML. It's JSX. I'll tell you more about JSX. So JSX is JavaScript plus XML. So JSX is just a convenience for writing HTML. So React code is all JavaScript. It's not HTML, but if I'll show you it better. More clear with this one. So this lower level API of creating divs on the page. So if React provides this API, and if as a front-end developer I have to create the whole app using these APIs, it's generally not very comfortable for front-end developers. So they have provided this convenient syntax. They like this, but this there's a pre-compiler which is going to translate all of these JSX code into pure JavaScript code before it's actually served to your browser. So if you look at the code, if you look at your JavaScript file in the browser, it will not have any of those JSX. So it's not HTML, and though it's also safe from security-related threats which HTML injection can bring. So that's not the fair. Okay, so we'll get more into how components really work. So I told you components in React are state machines, and input to the component is props and state. Let's get first into what are props. So generally your app will have various components: a parent component, a nested components, and even nested components, child components. So, and the data flows down through this component tree. If parent app over the data to child app, it's done using props. So I'll show you this example. Now, a very basic example you can see here itself. So here I'm passing down the name to hello component, and hello component is accessing this name as this.props.name, because name is a property for the hello component. A relatively more big example is this comment. So I made comment component. So React component sort of very nicely support composability, reusing, and so if you see, I have one parent component, this comment list. I have mounted comment list on DOM here, and that's the comment list. I have 3 comments which I want, and I want to show all my comments on the page. Now I made this comment list component, and which actually receives and its prop the list of comments. Now it iterates over this list of comment, and I've created another component which is comment, and it will pass this comment to this comment component, which will then show the actual comment. So the comment list is going to use this comment twice for each of these comments to actually get the result. So the result of this render will be used by comment list, and it will actually return the whole of the div state, and then React will do its own math and calculation over that state, and it will render the real DOM to the div, which is an ID container. Okay, that was about component props, which is a very easy and a very simplified and very powerful concept. Now I'll come to component state. So components have also just a moment, a component state. So as I told you, components are like state machines, and Props are what is passed down to the component, but then component are subjected to other things also. They are subjected to things like a user, which is doing interaction with the component, then things like time changing. There might be a component whose state depends on time, depends on location, depends on user inputs, and might be depends upon some backend delivering data to it. So all of these are handled by the component by its state. So you can specify the initial state of the component, and I've added a state variable to this component, which is one of the comments will be my selected comment, which is by default none. And at some point, I can select a comment by clicking it. Now, this is an information which is local to my component. It is not like passed down to the component from the parent component, but it will be maintained at the level of component list, that what is my selected component. So I add that data to state. By default, it's blank. Then I add a function called to update the state. This .set state is what we call to update the state. So in this case, I've added in the child component a method on mouse down. So as mouse is down, it will call the parent component's method, set selected component, and it will pass the comment, and then this will set the selected comment. So if I do a mouse down on comment 1, you see the selected comment is comment 1. If I click on comment 2, the selected comment is comment 2. If you look more closely, here the comment is calling on mouse down function. On mouse down, it's calling this function set selected comment. Set on mouse down. On mouse down is calling this parent function, which is setting the selected comment to this. So the child function is calling the parent function, which has been passed down to child function in props like this. And in the parent component, it's setting in state the selected component. And render method always responds to change in state and props. So whenever the state changes or whenever the props changes, render will be re-executed and re-rendering will be done. That gives a lot of control to the developer over the state of DOM. Even render function, I can control that on change of which props to, or on change of props to what value I need the component to be re-rendered. So that's actually a lot of possibilities. So like recently I had a scenario where I wanted images to load on my component only after everything else is done, so that image don't take a lot of network, because the requirement was to develop something for mobiles, and the image should come into picture only later, so that the page loading goes smooth. That something like that is so easy to handle with React, because your image tag is still in virtual DOM, and I can control that, and that this should not be rendered into actual DOM unless some event happens. So what's going to be the output of your component is totally in control of, which is because of the inherent functional nature of the React components, like a function and a state machine. Let me tell you more about it. Yeah, so this talks about how you can nest the components and reuse the components. And reusing it's a good practice, because reused components are more tested and they isolate the complexity. Now, this is like another really nice feature of React components, which I like a lot. So in case React makes when the inputs on your page controlled. So I can probably show you some Okay, there was a fiddle. No. So with React, even your inputs can be controlled. So the state of your input is not determined by what what events user is creating. So generally in browser, the state of your input is controlled by browser. So if you create a focus event and then you create key down events, your input will start showing what keys are you pressing. But with React, you can even control what are your inputs going to show. Because if you see, inputs are actually the only place where users really put in data. So at all the other places on the browsers, users are actually only generating events. And with inputs, it's event which is kind of communicating data in a more textual way, or in a way like true, false, if it's checkbox or something. With React, you can control these inputs. So the user events are communicated to you, but the state of input is controlled by you. So it's only when you actually change the input value that the input state changes. Let me just check. There was a fiddle to show this as well. Oh, sorry for that. But okay, yeah, this is the fiddle. So how input can be controlled. You see, in this case, I have specified value. This is my simple React, very simple React component, which is 2 inputs, and this is a controlled input. This is an uncontrolled input. React supports both, but controlled inputs are great in a way I'll show you. So the value of this controlled input is actually mapping to a state variable, which is val1. Whenever this input is changed, I call this function update val1, which just updates the state of this input. And so if I type anything there, I see it's changing. But now if I get rid of this on change, you'll see that, okay, I need to run it again. Even if I type it, there's no change, because the state of this input is totally controlled by this state variable. And since I'm not updating the variable, the state is not going to update by itself. So this DOM component is not controlled by browser, and it's not showing what the user is entering, but it's purely reflecting the state of your component. And the state of your component is val1 has the value val1, and it's going to reflect that unless I change the state of the component by using this onChange method. And React also supports uncontrolled inputs. If you're using a default value, that makes the input uncontrolled. So whatever I'm typing here is going to be reflected right there, although I am not updating the state. And so React supports both, but personally, I like this controlled input components so much that it gives a total control to me. So if the developer, if the user is entering a value which I don't want to see, if it's like a garbage value or a value which I don't allow for the field, I have total control to not let the user enter that. Okay, now the event handling model. So React has synthetic event of its own. So it listens to the browser event stream, and it creates its own event object which comply with the W3C recommendations, and it passes those objects down to your components. And as you might have already noticed on these, we have these camel-cased event listeners. which can listen to these synthetic events, and then you can get the data out of these events like you do on any other browser DOM event. So everything which DOM library supports is supported by React's synthetic events as well. Yeah. That was, and then of course, as you've seen, you can pass down callbacks as props. So this was like very visible in this example. Example of the comment list. So if I have this comment component, and I can pass down the callback as a property to the component. So when you click, when I'm clicking the comment, it's actually the parent function which is called. So not just data, but callbacks can also be passed, because very often we want the state of parent component to actually update as whenever I execute an event. So you can pass callbacks as property. So in whole, with this nested component structure and flowing down of props and state, React actually largely favors unidirectional data flow. Unidirectional data flow is a concept of Flux, but React has a structure which really favors it. So on your app, React components will be generally like this. If you're using, if you're building the whole app using React, your whole app will be a single React component, which will have a lot of nested components, nested and different levels of nesting, and the data will really actually pass down the props. And this is the kind of unidirectional data flow which React supports, and it goes so well with other architectural concepts like Flux and Redux. But I would say it's inherent of React, and that is what makes React applications so predictable. So if I have a data in my root component, then I'm kind of guaranteed that every child component has received that updated data and has a correct state. So the challenge initially which Facebook had, which motivated them to look for another solution for front-end development, and which motivated them to come up with this concept of React, was it was really hard to maintain the state of your UI in a way that it's guaranteed to be consistent at every moment. So suppose there's a UI component in the bottom of the page which is using the same data, and there's a UI component on the top of the page which is using the same data. If you have done front-end development, you can, or mobile development or web development, you can make sense how difficult it is to make sure, to just guarantee that at every point both these places will be in sync, and they'll be reflecting the state of the data which is actually maintained in the front end, and that's a huge challenge for single page applications state management. And React actually answers that in an awesome way. So if your state changes, and from your root component, this information just flows down, and all your at every change, what React does is re-render. So whenever there's any change in the application, React is going to calculate, it's going to do all the math and calculate the state of your application, of your entire virtual DOM at that point in time. It will execute render of all the methods for all changes, and the result of all these is a virtual DOM. Yeah, because it may lead to, like, it's very expensive. So if there is an on-click event somewhere down on my page, the whole page is going to re-render. But it's done in such an optimal way that render function of all the components is going to get called. All the components which can be impacted by that event. And then React is going to calculate the virtual DOM state at that point in time. Then React is going to diff it with the state of virtual DOM previously, and it will update your actual, from those diffs, it will update your actual DOM in very, very optimized way. So yeah, as you can see, DOM, in your front-end application, the most expensive operation is DOM mutations. And those are the things which take most of your time. So if you're working with a framework which provides you two-way data binding, you end up in having a lot of listeners, which kind of consume your a lot of browser execution cycles, and then you have a lot of DOM updates. But what virtual DOM does is all the updating, all the changing, and all the re-rendering, all of that happens at the level of virtual DOM. And then in a very optimized way, it batches all the update, it calculates minimal diffs, and it batches the update, and then it updates the actual DOM, which the users will see. And because of this stateful nature of React component, that kind of guarantees that your app is consistent at any moment in time. So it cannot happen that your header is not updated while your footer is updated, or there's a data change which is not reflected by application. It cannot happen, because at every change, it's going to recalculate your whole UI and all the components. So yeah, that more clearly shows how virtual DOM work. So if suppose the change is at these two components which you see in the left, so it will calculate that which all components, which all part of the DOM are going to get impacted, and it will just do that math, and it will re-render only that part of the actual DOM. So this diff and calculating the minimal differences. Also on the right, which you see these 4 components, it's going to call render of these 4 components, and it's again going to do a lot of diff and optimization and batching updates of all of those, and then ultimately go on to update the actual target, mobile or browser or whatever it is. Yeah, so yeah, React is, since it has been open sourced, this is the level of adoption React has, and a lot of very good and very reputed companies have started moving their front-end development to React.js because of the kind of reliability it provides them. And reliability in UIs has been the biggest challenge in the web development space. Yeah, that was it from my side. And I think we can have a Q&A session now.
Yes, Jyoti. Thank you for taking us through that session, and we are already getting a couple of questions. And I would like to request all our listeners that if you have had any questions throughout the presentation, now is the time to send them in, and we'll take them up with Jyoti. So the first question that we have here is, could you give us some examples of virtual DOM?
Okay, yeah, I'll tell you more about virtual DOM. So virtual DOM is a concept that has been around for quite a while. React was not the first one to bring it over. A lot of front-end libraries had virtual DOM. And yeah, the pain point is, as I told you, the main trouble with this, if you're doing the UI development, the main trouble is updating the DOM is very expensive. Virtual DOM kind of comes in there, and so all of these divs which you're saying, this is not the real DOM. So it's going. This is a DOM which is maintained at the level of React. I showed you this React syntax without JSX. So this is how it looks, and this is a DOM which React maintains, and this is like a whole nested tree, and it's actually very complex. It complies to all of the W3 specifications, but this by the library which compiles it down to how your actual DOM will look. And this is a huge optimization for any front-end library, because as I told you, the DOM updation is where it really hits front-end in terms of performance. So I'm not sure how exactly I can give you as an example of virtual DOM, because that's something which is handled by the library internally. But all of the JSX that you see in the code here, all of these are compiled to in-memory DOM representation, which is then translated to the real DOM representation by the library.
Okay, all right. So the next question we have, and this goes down to something very basic, is what exactly is a component in React.js?
Yeah, as I told you before, a component in React.js is, if you come from a background where you have used other libraries like Angular and another libraries there where components have a template to them, and then you do data binding, and effectively you have another widget on your page which you can be using. React components are not that kind of template. React components are functions. So if you closely look at the definition of a React component, we are calling this React function, which in turn just returns us a function. They are pure functions, and they, as I mentioned, they are state machines. So what are functions? You have an input to the function, and the function has an output, and it's completely reproducible. So and it's determinable. So if your input change, your output change, and it has no side effects. So if I'm giving my input XYZ and there's some output, and if I again give this input, the output will be exactly same. So that's the kind of reliable behavior a function really gives you. And a React component is a state machine on which props and states are input, and the structure of your DOM is the result of the function call. And the function is always going to give you the same result for same inputs, and that is what makes your UIs so predictable. Because if I have my whole React app, a whole React app is a big function, and the output is a DOM. But if my inputs will stay the same, the output is going to stay the same, and with every change in input, the output is going to change. So you see this unidirectional data flow, which is from what I'm inputting into the function is doing an output, which is the DOM state. And there's no two-way data flow. Your DOM cannot update your components, but the state, your DOM and the events on the DOM are actually again input on the function, and then the output is again the DOM. Again, you make an event or you make a server-side call, and data is again input to the function, then output is a DOM. So React component, in short, is a state machine, and the output is the state of your UI. Yeah.
Okay, so you're saying the components in React.js are something that is fundamentally different from a component in, let's say, any other JS libraries?
Yeah, they're actually very different. So as I told you, in other JS libraries, components are generally templates, and they're more like widgets on the page. Yeah.
Okay. All right. The next question we have is how to make a dynamic UI in React.
That has React is about dynamic UIs. If you're making a static UI, you really don't need a JavaScript framework, because You can handle that with just HTML and whole page reloads. But it's when your app starts having a state, and because you have data which is maintained at the level of JavaScript, and your API, your UIs become dynamic. That is when you really need a library. And yeah, how to make a library is like how to code using React, and it's a question. And learning something that needs a lot of time. So I would suggest that you go over to React site and check out the tutorials and the docs.
Okay. Next up, how is React different from AngularJS?
Yeah, React and Angular are fundamentally very, very different. So Angular is based more on that MVC model. It's more of a full-fledged framework. It's an MVC model, and the primary feature is two-way data binding, and you have controllers, you have sources, and more of that. And React is an entirely different approach to your rendering. It's functional code and virtual DOM. So both are very different. And I personally prefer to use React for for almost all of the front-end development. I do a lot of development using React, and yep, also done some cool open source projects. You can check my Git repo. But yeah, they are fundamentally very different, and I'm not a big Angular fan anymore now, but Angular is also, which is like very well justified, and they're taking it forward with Angular 2 in a very good direction. But you can really compare these two.
All right. You're saying both of them have very different use cases and very different purposes, and it wouldn't really be fair to, make a comparison of which is better in that sense?
Yeah, I mean, both have the same use case in a way that both are used for UI development, but they both approach this in very different ways. So if you're for any average app, I think small-sized app both can be used really nicely. But if you have an app which needs a lot of reliability, maintainability, and performance, then I would say better go for React, because those things, as your application size starts growing, it gets a lot of complexity, and then it becomes really hard to handle that in frameworks like Angular. I showed you this slide. This is what ends up, and there's a lot of models and a lot of view and a lot of data flow, which is not deterministic. So in those cases, React is better.
Okay. Next up is about the parent and the child components example that you took. So as per your example, the child component can invoke the parent's event, and but can a child component change the props data of that parent?
No, props actually flows down the component. So there's no point in child changing the props of the parent. Child can definitely change the state of the parent. So this is the example. And thus you see this is a parent component, which is comment list. It has these 3 comments, and the parent component has an instance function which updates its state. And what it is doing, it is passing down this instance function as a property to the child function, and then child is calling this when it's clicked. So this will in turn land here, and this will update the parent state. So parent will re-render, but the parent props are here. So there's no way a child can change parent props, and that's also not a flow that kind of makes sense. But yeah, the child can definitely change the parent's state using the callbacks which parent passes down to the child. Yeah.
Okay. The next question is, how do you make two-way data rendering in React?
Yeah, so as I told you, two-way data rendering in sense that if you compare it with other frameworks like Amber and Angular, doesn't exist like in React. A very, very basic a primary feature of React is the unidirectional data flow. So React favors flow of data in one direction. So for instance, maybe I can show you a better example, but yeah, take example of this basic component app. So all the data resides here with the comment list, which is here I'm initiating the parent component, and this comment data is flowing down to the parent component, and from parent component to parent's child component, and the events which I'm generating. So like I generate this click event. Click event is again changing the state of the component. So if you see, it's like this. So you have data, and then you have events, you have state. It just flows down like this to the DOM. So a direct two-way data binding is not possible, but what you can do is from the DOM, as events happen, this will again change the state. The component will execute, and again the output will be updated. So that is how you make sure that your UI update, and it brings in a lot of reliability as well. So in case of Angular, suppose Angular has this two-way data binding, and I'm changing, say, I was mentioning previously that if there's a change in the footer, the header may not change. Suppose I'm changing, I inputted the footer, and it changes right away because there's a two-way data binding. But my header is not yet changed. What should be happening? So this two-way data binding has this inherent flaw that information is flowing back, and it's result in this kind of a crisscross where views are updating models and models are updating views, and a non-deterministic data flow and unpredictable UI. So in case of React, if an event is happening, the event will again go back like this, and it will update the state, and the result in a very predictable way will update the whole UI. So a two-way data binding in conventional ways like Angular and Amber is not possible with React.
All right. Next up, like in Angular, the HTML can be templated and put in separate files, but in React, can that be done, or does it have to be inline?
Yeah, that's a limitation. JSX has to be right there with your component. So as I mentioned here, so the component combines DOM rendering and display logic, and you really cannot separate it as a template anywhere else. Yeah, that's a limitation. Not
Okay,
exactly a limit.
Yeah, so it has to be inline.
Yeah, I personally feel it's not a limitation because as a front-end developer, it gives me more control over it and more knowledge of how exactly my DOM is changing. To me, it's an asset, but a lot of people who come from non-front-end, I mean, you come from a background where you have done mostly backend development or templating, and you take this to as like really, really segregated. You don't enjoy doing that a lot, but I think it gives a lot of power to me as a front-end developer when the DOM rendering and the display logic is right there together, and I'm changing that. Yeah. Yeah.
Okay. Next up, how can React be used?
React is kind of React doesn't makes any judgment about your backend integration or React can be used with any other front-end or backend technology or library, as long as you have if you have using Drupal and you're like well-defined data flow, you can just plug in React. In fact, you can use React even with other front-end libraries like Angular and Amber. So That's perfectly fine. You can just plug it in React component anywhere, and the communication with Drupal, as you might be doing right now, you can just using their API or RESTful APIs, you can just continue doing that. React is not opinionated about it.
Okay. All right. So next up we have in React, we don't need to refresh the page after any change in code, just like in any other JS, or is there like something different in React?
Yeah, so as I told you, this rendering to an abstraction layer, which is above DOM, opens a lot of other possibilities, and hot reloading is one of those. And there are very good libraries which you can use together with Webpack to achieve hot reloading while you're developing React components. So unlike other libraries, for instance, in Angular, you have this live reloading. So as soon as you make a change in your code, the browser will refresh by itself, but then the state of your browser will go away. So if it's a half-filled form, it will be wiped out. But with React, while if you're coding and while you're making changes in the code, your actual browser will be hot reloaded with all those changes while the browser state is maintained. Yeah, that needs kind of configuration with Webpack and using a different some hot reloading node modules there.
Okay, great. The next question we have here is that can we update the same component on some event on that component?
Of course you can, because I showed you the React components have the state in this case. Yeah, this is it. So in this case, it's mouse down, and I'm calling mouse down of this component. Plus, I'm calling here. I'm calling an event of the parent component, but I can change the component here itself. So maybe I can quickly show you. Suppose I declare that this component has a state, which is let's say prefix. So if this component is clicked, I'm updating the state. And prefix is clicked, and I'm appending this prefix to the actual comment. And I'll run it. So if I click it, oh, it's prefixed by clicked. So you see, of course, an event. I'm creating an event on component 3, and then the component 3's state is changed as well as the parent state is changed. And it happens like so smoothly. Yeah. Yep. So of course you can change the state of the component when an event happens. That's kind of local to the component. I hope that answers. Yeah. Yeah, I hope that answers the question.
Hello, Jyoti, can you hear me?
Yeah. Yeah.
Yeah. Yeah, so the question is, how is React more reliable as compared to other JS libraries?
Okay. Yeah. As I told you, I was while I was discussing this two-way data binding thing with Angular. Now, if you take the case of, say, any other library, I'm using, say, vanilla Jquery, Angular, or any other library, and I'm making an input in my application. which is an input which I want to be reflected across my application. There's a menu which should be changed. There's some data somewhere which should be changed because of this input of mine. If I'm using any other library, there's no guarantee that will happen, because after I input, browser will update the input right then, but then it will. There's no guarantee when actually that input is reflected in JS and when the JavaScript goes and update other part of the browsers. So that's kind of, that can not be guaranteed with other UI libraries. But if I'm using React and I generate an input, that's going to change the state of my React app, and it will change a lot of it will be reflected by all the components, because as I mentioned, React re-renders the whole app on each change. So that data change is going to call the render method of all the components on my page, of header, of inputs, and just everything, and then all of those will change together. React will calculate the new virtual DOM state, and then it will update the actual DOM. So that kind of guarantees that if there's a change, the whole application is going to reflect that. And in my experience, it's you can do it in very fast and very optimal ways if you're using React, and making this possible in any other front-end frameworks in a reliable way is almost impossible.
Okay. Next up, how does React interact with the backend system to render the HTML?
So mostly you backend exposes APIs which React consumes, and it does like any other front-end framework. So React is not different or opinionated there. Yeah, server-side rendering is another backend thing which React supports, but I think that that's not what's meant by the question. But it interacts with backend like any other framework using Ajax or Fetch or any HTTP protocols which you might be using. Yeah.
Okay. What is to be done if we have a lot of updates to make on the same component?
That's fine. So React components are great at handling these in very optimal ways. And in my experience, these applications really perform well. So there's a synthetic event stream which React is managing. So so in this case, this is my one component, and if I create events, you see this is changing with each event, and so React is like great at handling these event stream like any other library, just more fast and more optimal.
Okay. Next question we have is when or how do we decide in which case to use React?
Yeah, so that's actually decision to use any technology for your project depends on a lot of factors. It depends on the team, on the devs, on their comfort level. But I personally use React for all my front-end development. But I would say that if you are developing a big application and predictability is important for you, reliability, maintainability, performance, these things are important to you, and it's huge and it will grow in size. And then React can help you in a big way if your developers understand it and leverage it nicely. Nothing like that. And otherwise, for an average application or a small application which is not very demanding, you can make any technology. I prefer to use React for all of those, but then it doesn't make a big difference there. Yeah.
Okay. Can we change the state of P2 parent component when the child component of parent P1 is being rendered?
Okay. Why would you want to Okay, so there's two parents, P1 and P2, and child of P1 is rendered. From P1's
Yeah.
child, you want to change P2. Yeah, as I told you, in React component, the change might be happening in any corner of the application, and you can actually reflect it in the whole application because um, I need to pass this information up to the parent of P1 and P2, and then both of them will be updated. And you need to think about how the event data is going to flow. So generally, in React, you have, if you're using React with some containers like Flux, you can generate your action, which will change your store, and the information will flow down. But if you're not using separate action class, you can pass down callbacks to the child of P1, and this callback will update the parent of P1, and that update will in turn be reflected by P2. So that way, you need to update the component one level above, or if you're using an action class, then you can update the action class, so it will update the root component and the update will flow down. So of course, yeah, possible.
Okay, I think we are at the end of the session today, and we have just one last question here. So should I choose Redux or Flux for React.js, and what is the difference between the two?
That's interesting. I would say Redux is just another nicer flavor of Flux. It's very important as a developer for you to understand the fundamentals of Flux and how Flux support unidirectional data flow and how you can leverage that for your application. Like it was this example of P1, P2, and the data flow. We need to be very clear about the concept of unidirectional data flow and those Flux concepts. And then, in my opinion, Redux is a very well adopted and a very mature, well tested, well supported library implementation of Flux. And you can go ahead with using Redux as well for your project. But vanilla Flux is also nice. Redux gives some things on top of that, which are again nicer, but more important is knowing this concepts behind Flux, which Redux is also leveraging. And then maybe prefer Redux because of the community support that comes with it.
Okay. I would just like to tell all our listeners that we have reached the end of the session, and we have had a lot of questions, and thanks to all of you for being really engaging audience this time. And if you have any more questions, you can directly connect to Jyoti on Twitter and have your questions answered. And before we end for today, we have just one last question, which is React a pure use of JavaScript library, or can we use Jquery also with React?
Yes, so as such, React library itself doesn't add anything to JavaScript. It's pure JavaScript. But as I told you, you can use React with jQuery, you can use React with Angular, or you can use React with anything else on the front end. And that works well. Yeah.
Okay, great. And so with that, we have come to the end of this webinar. And I would just like to thank Jyoti for patiently answering all the questions. And for patiently answering all our questions. And I'd like to thank all our listeners for being such an engaging audience. And I think we learned a lot about React.js today, and all our listeners would be dying to go back and use it for their web app development. And so thank you again, all of you for joining us today. And I would also like to announce that our next webinar is on the easy performance wins for your Rails apps, and it would be hosted on the 10th of August 2016 and would be led by Aaron Cruz, a freelance Rails developer and open source contributor. For registrations and more details, you would be getting a mail from us, so stay tuned. And thank you again for joining us today, and hope to see you in the next webinar. And also, let me tell you, you'd be receiving a mail with the recording and the slides, and you can also get in contact with Jyoti to have the rest of your questions answered if you have any. And so that's it for tonight, and thank you all of you. Thank you for joining.
Yeah. Thanks everyone.